After lunch, 2:30, we'll have a talk. Maybe I will cover for 1 hour. It's related to rapid tooling. That is related to not level of the research thing. Okay, so there we can learn about that. What are the things there for the industrial point of view? Okay, how to make the use of this additive manufacturing for making a mold and patterns, and that we'll see today. But after that, we can have a demo session. Okay, so already I've just collected the information, like around 80% of participants are showing interest. So in that case, yeah, we can do it by today itself. So, okay, so is it the feedback form is working?
Working, sir.
Yes, sir. Nice. So then, yeah. Over to you, Saravanan, please.
Yes, sir. Thank you, sir. Very good afternoon to everyone. We are here to witness the live demonstration of 3D FDM printing of polymer components. We here have an equipment for 3D FDM printing, which is Ultimaker S5. This is the state-of-the-art printer in the case of FDM printing, as this printer has the capability to print two materials simultaneously. It is capable of printing polymer based components which can be printed, in which two materials can be printed simultaneously. So this printer is compatible to print polymer composites as well. The first thing that we witness in the case of 3D printing is that this we need to first create a 3D CAD data. The 3D CAD data will then be tessellated or converted into an STL file, and then we need to upload it into this Ultimaker Cura software. In this Cura software, only with this Cura software we can slice the component. As we all know, after the component gets tessellated, it gets converted into. After the component gets tessellated, it holds the G-code data of the entire structure. That means once when the component is in 3D, then we just tessellate it. That means we create triangular sections on the component, and then we slice it. While slicing it, we need to give certain parameters. Only then we can slice it, and we can generate the G-code data, which is then fed into the software and which helps the printer to print the component. As you can see, this is the software that interfaces the Ultimaker S5 printer with the computer. And the beauty of this printer is that this printer can be accessed from anywhere on the world. That is, this printer is wirelessly connected with the computer. Just the IP address from the printer can easily get it accessed by anyone at any place of the world. First, we feed the STL data that we generated for our CAD model into this printer, and from the STL data, we need to adjust the different parameters that we need to give for the printing, and then we need to slice the component. Like, first starts with layer thickness. Layer thickness or layer height is defined by the distance between each and every slice that a component takes. So if we give the distance, then we need to consider about the wall thickness, top thickness, bottom thickness, and all. As we all know, the component is not entirely to be printed in the same consistency. The component will be printed with uniform material at the edges, whereas it remains hollow at the interior. So we need to adjust these parameters: wall thickness, top thickness, and all, and then infill density. Since most of the time these FDM components, printed FDM components, which are mostly used for prototyping, we need not have the component to be entirely filled with material. So we can alter the infill density. That means a part of the component can be hollow, and this reduces the material consumption in the process. So infill density can be altered, and printing temperature. The printing temperature is decided in the way that the material that we use should be properly fused and should be converted into a semi-solid state. So these and the last one is the build plate temperature. Build plate temperature is very much important because the residual stress of the component will be reduced due to temperature gradient. And we can also alter the cooling, travels, the speed of the extruder, and many other parameters that we need. And we also can do dual extrusion. That means we can also print two different components, which is helpful in the process of polymer composite printing. So let me show you a live 3D print, live component which is being 3D printed. We are now printing a honeycomb based structure in the machine. This is done by as the steps I told, it is done with the help of that. And here, as you see, the movement of the extruder moves in such a way that it is fed with G-code data from the tessellated and sliced component that we fed in, and which is moved with the help of three different stepper motors at the end, which actuates the movement of the extruder, and this prints the component on the whole. Then we come to some of the interesting components that we printed in our college to understand the process of printing. First is a flexible CAD. As you can see, the component is entirely being printed and assembled in one single step, which in the case of subtractive manufacturing, when we take some other method to print except 3D printing, the assembly will take a lot of time, as well as it is very complex to create such a feature, whereas it is completely manufactured in a single go. And we also, as stated before, we can also, while printing itself, we can assemble the component, which is evident with the help with this interlock chain, which is completely printed as well as assembled on the go, as well as this helical bearing, which consists of helical gears inside, as well as it can rotate and as well as which is done in a single go. And we also printed some threaded nuts and bolts, which are we also printed some threaded nuts and bolts, which are manufactured in a single go. And this is a statue, the model of the statue that we printed, which the statue is at the entrance of our campus, which is then laser scanned from the help of which we obtained the CAD model of the statue. We then printed it with the help of our FDM printer right here. And these are some of the components that we printed with the help of our printer, and this shows the different infill shapes that we can give into the printer. And this infill shapes determines the stability of the component that we do. And that's it. Let me now hand over the session to Mr. Vishant, who will explain about 3D metal printer.
Good afternoon, ladies and gentlemen. Welcome to additive manufacturing facility of IIT Palakkad. My name is Vishant, and I am staff at IIT Palakkad. I support student and our research team to fabricate parts in our 3D printer machine. So the machine that we have got here is from Germany. This is EOS M290 machine, and we basically fabricate parts on super alloys like aluminum alloy, titanium alloy, inconel, maraging steel, and others. Okay, I'll quickly introduce to the processing chamber of this machine. As you can see, this is the processing chamber or the fabricating chamber. It has got three platforms. This is the base platform, and this is the dispenser platform, and this is the collector platform. Okay, and this has got an elevating system. That means these platforms can move up and down with a very high positional accuracy. This base platform can move at a position accuracy of 5 microns. So over the base platform, we used to fix the base plate, which is over which we build the parts. So base plates are usually kept on it and we screw to it. And this base platform has got the facility to heat up the base platform also. So this can heat up to 200 degrees centigrade based on the material requirement. And on to the right that you see here, this is the dispenser duct, I see. And currently, as you can see, the platform is at the topmost position. This can go down, and here we deposit the fresh metal powders through sealing process. And the main function of the dispensing duct or this platform is to feed metal powder to the recoating system. So this is the recoater part, which can move right and left. This moves like this. The main function of the recoater is to spread the powder onto the base plate evenly and evenly. Okay. Now on the left there is another platform. You can see this is the collector platform. The excess powder which come from the dispenser platform goes into the collector platform. So usually the waste powder falls onto the collector platform, and the thin layer of powder which remains onto the base plate gets exposed to the laser source. So the laser source is at the top. Okay, and this machine has got a laser power of 400 watt and with a laser scanning speed of 7 meters per second maximum. So the as the laser spot falls on it, the metal powder consolidates and forms the part. And by now you will be aware that how the parts is being formed. So I'm not going into the details of that. Apart from that, it has got a few sensors also. Like we have got an oxygen sensor here. So since we are dealing with the highly reactive materials, we usually prefer inert atmosphere while the building process is taking place. So for inert atmosphere, we used to supply inert gases such as argon and nitrogen, and the oxygen sensor in the process chamber make sure that the oxygen level is very low. Thereby, we know that okay, the chamber is full of inert gases. And additionally, we have got an overhead camera also. This camera captures images of the platform immediately after the spreading of powder as well as after the exposure of laser. And these platforms can be operated, or the all the process parameter establishing takes place through this monitor. This has got an interface wherein a 40% of the works we do. We move the platforms up and down, the flow of inert gas, the oxygen concentration, all those things can be monitored through this monitor. And looking as a whole to the machine, onto the right side of the machine, there is the controller part. On top of it is the optics chamber, where all the lens, the optic systems are there, galvanometers and the FTTL lenses, all those things are situated there. On the left side of the machine, you see two chambers, the two filters here. So that's the primary filter and the secondary high purification HEPA filter. The primary filter functions, it filters out all the particulate matters from the inert gas flowing from the process chamber towards the outside. And then it goes to the secondary filter, which is high efficiency particulate air filter, HEPA filter, which filter out even the minutest particle and then leaves the inert gas to the atmosphere. And apart from this, there are two more accessories. One chiller unit we have. So this chiller unit is for keeping the laser at its working temperature throughout the process. And this another accessory, which is the bed separator, which is basically a vacuum cleaner, which is used to suck out the unwanted materials left out in the process chamber. So that is all about the machine. And now this machine is associated with a processing PC here. So here you can see how the process is taking place. Currently, we are not running any jobs, but we have got a video for you. So you can see that the laser source is being embedded onto the powder bed. So currently, this is the base platform. As soon as the exposure ends, this base platform will go one layer down, and you can see that. Yeah, these are one layer down, and the recoater brings the fresh layer of powder onto the exposed area. Now you will see a fresh layer there, and again the laser power exposes, or the laser source exposes, and this successively continues until the final part is prepared. So coming to the software side, we usually deal with two types of softwares while before working onto this machine. The first software is called Materialize Magics. Materialize Magics. This is a job preparation software, we can say. Basically, what we do is we check the CAD file which we receive for printing, and we check for any errors in it, like triangulation errors or overlapping errors or any kind of errors. We try to fix it. Once that is done, the software is used to generate the support structure. We build the support structure based upon the optimum orientation of the part. And after building the support structure, we export this file to a proprietary software of the machine EOS, which is called EOS Print. And as you can see, there is a job file being printed. This software helps us to place the part onto the base platform. So as you see, this is the base platform here. So these are part placed. So there is we need to follow few criteria to place the part. So that we do. And in the software, we set all the processing parameters like the laser power, scanning speed, the hatch distance, the all such parameters we set in the software. So once that is done, we expose this file to the machine, and where the machine take up this, and we start building the process. And to the last part, I would like to show some of the parts which we have printed a lot of parts, but a few parts we have kept to show the capabilities of this machine. You can see these are some of the porous structures which we try to print. These are lattice structures. So we even tried to print a few bone structures also. So these are cylindrical coupons on bone structures ranging from 100 microns to 300 microns. So this kind of structures, these are all ALSI TI64, TI6AL4B, and we have materials parts printed like this. These are just to show our students and to motivate them towards the 3D and its capabilities. Okay. So that's about additive manufacturing facility. We are registered to IITM also. For any collaborations and all, you can write to Dr. Keshavan, who is in charge of this facility, and you can also write to CFM Engineering at IITPKD.ac.in. Thank you so much. I would like I request Dr. Subbu to take on.
Thank you, Dr. Vishant. Thanks for that. It's a nice demonstration. Now I request Saravanan to go near to FDM printer. After the FDM printer demonstration, he started to print a honeycomb structure. I think, yeah. Saravanan, can you show the honeycomb structure printing?
Yes, sir. Yes, sir. Since our component being printed is around 1.5 hours to be done, so we just plan to do the EOS printer stuff first, and then we are planning to do the speak about the printing mechanism that is taking place. The thing is that the printer is fed with a spool made of polylactic acid, blue polylactic acid, which is attached to the backside of the printer. From this spool, the material is taken in with the help of a stepper motor and is fed to the extruder. As you can see, the extruder consists of two different nozzles, two separate nozzles in which another lateral material can also be printed. After the material is after the material enters into the extruder consists of a heater and a cooling fan. The heater of the extruder is maintained at the temperature of 200 degrees centigrade, which is very necessary to completely fuse the material of polylactic acid into a semi-solid state. As soon as the material reaches into semi-solid state, the extruder pushes the material through the nozzle, and the material from the nozzle gets deposited onto the surface that we are printing on the component. The nozzle diameter of the printer is around 0.8 mm. So the layer thickness that we can maximum achieve with the help of the printer is around 0.8 mm. So each and every layer that we print is uniformly maintained in the range of 0.1 to 0.5 mm usually. And we can also move below 0.1 mm at certain cases. And speaking about the construction of the machine, The machine is constructed with the help, the movement of the machine is controlled with the help of 3 different stepper motors. As you can see, 2 of them at the top, and one is fixed with below the machine, which is hidden inside. The base plate is made of glass and it consists of a heater as well. Since we need to maintain a uniform base plate temperature, which is very necessary to reduce the residual stresses as well as the easy removal of the particles, the base plate is uniformly maintained at the temperature of 60 degrees centigrade for this polylactic blue material. And as said before, the component being sliced and the component is sliced, and each and every slice will have its separate G-code data. The G-code data is fed into the control unit of the printer. With the help of the G-code data generated, the stepper motors are moved, and the rotations of the stepper motors are properly adjusted with the help of the control unit, and with which the extruder is moved with 2 different axes. That means the X and Y axis of the X and Y axis of the print is given to the extruder, whereas the Z axis movement of the print is to be given to the base plate, which gives a steady movement and is being followed universally at the present time. And coming to the different capabilities of the printer can also print 2 different materials simultaneously. And the thing is that when the material extruded is of uniform or definite pattern, the printer takes a specified infill pattern. That is like when we are giving the component, if the component is not to be completely fully filled, which is to be defined by a specified infill pattern. The infill pattern can only be given only when the material has a specific thickness. As you can see, now we are printing honeycomb structure, which is not that porous and all, so it is completely filled. That is, the infill density constantly remains 100. But in some cases wherein the material has some hollow structures in between, the infill is to be given with some definite patterns. This is the infill pattern of rectangles that we tried, and this shows the infill pattern of hexagons. Sorry, the camera is not focusing properly. This is the infill pattern of hexagons, and this is a star infill pattern. And this is a specified infill pattern which can give a flexible structure at the mid and sturdy structure at the end, which is specifically given by our requirements. And this is a hexagonal infill pattern, and mostly I think we covered all the parts. And we can also print flexible structures with the help of this machine, like as you see in the clip, which is completely printed, and it can also be flexible. Like the machine is capable of that. That means the part that comes out is also can be made flexible by either modifying the shape of the component or with the modification in the infill pattern that we use. And we can also modify interlock structures like this, which are like completely flexible as well as made in a single go.
Yeah,
yes,
yeah. Thank you, Saravanan. Excellent demonstration. Thanks to Saravanan, Vishant, Bharat, Krishnadas, who are all there. Somasundaram, it's a really nice of you guys, because morning only we have decided, and then within short period of time you have arranged. Okay, I'm really thankful to all. Yeah, so now over to the participants. You have any doubt related to the setups? We are now happy to answer to your queries.
Sir, hello.
Yeah, please.
Yes, sir. Good evening, sir. My name is Sri.
Sir, the particular material that that Saravanan has just now shown, that that flexible type of material, what is that exact what is the material?
So this material is polylactic acid, black colored polylactic acid. Most of the material that we use is polylactic acid, and in some specific cases we also used polymethyl methacrylate, PMMA. We mostly use these two materials, sir, which is this flexible structure is polylactic acid.
Okay, sir. Thank you.
Yes, sir. Thank you, sir.
Saravanan sir,
Hello.
Please, sir.
Could
Dr.
you
N. Jayan, yeah.
sir, filament you are using 3 mm only, no?
No. Yes, sir. The filament diameter is 3 mm. Exactly to be said, it is 2.84 mm, sir.
Yes,
2.84 mm
Okay.
uniform screw.
Because that's a problem, because even one of the participants asked on the day, some companies are saying that we have to buy their material only. If I buy a machine from a particular company, that company always insists that we have to buy the material from them. Then like that most of the companies are doing. The thing is, they will make in such a way that it will not meet the standard. For example, this particular brand, we have to use that brand material, then we are able to get a good surface finish. If I go with other material, first of all, it is not suitable because not getting the same diameter. Another thing is, even if I get the same diameter, that product output is not so great. We just faced a lot of problems. Okay, so better always. But in the things that while buying a machine itself, we have to ensure that the machine should have the capability to process the other materials also. That is the best way to. Okay.
Okay, sir. Okay.
Thank you. Any? Yeah, please.
Sir.
Yeah, please.
Sir, could you explain again how the nozzle is moving in different directions?
Okay, Saravanan, able to show the thing. Yeah, see, before going to that, you might have seen that in a lathe machine tool, okay, that workpiece is rotating, whereas the tool post is moving linearly. The synchronization of these two motions only finally producing the 3D like prod, correct? So that the same way here we have to have a combination of this nozzle and then the stage movement. That is only going to give your final product. Okay. See what happens that this glass plate is moving up and down, whereas the nozzle, which is attached with the method, like it's a kind of arrangement that it can move x as well as in y axis. It's a linear guides are there. Okay. So there it will move x and y axis as per our instruction, whereas this glass plate is move up and down. Okay, but still you want to.
Okay, sir. But I was wondering, like in x direction it is moving, and then when it is moving in y direction, how does it change its direction of motion? That's
just a minute. Like, Saravanan, are you able to show that thing? Are you?
Yes, sir. Yes, sir. I'll show that, sir.
Yeah. Okay. Can you see the guideways here? How it is?
Yes, sir.
Yeah. 1 minute. Because there also.
Actually, sir, can I explain that, sir?
Yeah, please, sir, Saravanan, go again.
Actually, Mr. Prasanna, the thing what happens is that the G coordinate data will be fed into the controller. After that, the G coordinate data will be converted, that corresponding to the G code data, that means the coordinate data, the controller will give necessary instruction for the stepper motor, and it will give the number of turnings, number of rotations the stepper motor need to do. Depending on that, the stepper motor will be connected to a belt, a belt, and the belt will be connected to another geared rod. This geared rod is in turn connected to the ends of the actuator of the extruder. So the rotation of the stepper motor will be directly converted into the linear actuation of the extruder with the help of the belt setup that is been done in the machine. So just the rotation of the motor will move the belt, and the belt in turn moves the extruder, and this positions the proper coordinate position that is given in the G code data. This is how it works.
Okay, but there are two guideways, right?
Guideways, yeah, they are belts actually. They are not guideways, I think.
But the setup moves on two guideways.
Yeah.
So when does it leave one guideway and stick to the another guideway? How does that work?
No,
if I
it
understand
is.
your question, sorry, sir. If I understand
Yes, sir, yes, sir.
your question, is trying to ask that X and Y, okay, both are like linearly independent, and now that is the case how it is moving in. Can you see that now? How it is moving in XY? Prasanna Mandal?
Yes, sir. I can see, but I'm a bit confused. Like,
Okay.
It is simultaneously moving, Prasanna.
Yes. I'm really Prasanna.
oh, okay. I got it.
See, Prasanna, in CNC, the beauty, in a CNC, like if you see, if you want to take a curved surface, okay, in general in CNC, it's not possible, okay, because always there is a step. Okay, you want to make a circular feature by any CNC thing. Okay, if you go very magnify and check, you can see the steps in that, because XY motion, that is a way that circle also can be plotted, or curved things can be plotted. So that is a limitation of all the CNC things. Okay, so here it is happening simultaneously because of this kind of mechanism.
Okay.
Fine?
Okay.
Yeah,
Thank
fine.
you.
And then somebody asked about any real-time product made by the 3D printer from IIT Palakkad thing. Like, yeah, like I got an answer from Dr. Kesavan. Yeah, impellers. They made the impellers, and then like they export the application of it. Okay.
Vishant, if Vishant is available, he can show those impellers. Vishant?
Yes, sir. Yes, sir. I can show. Yes.
Can you show some of the components printed using our 3D metal printer?
Yes, sir.
Any other questions from the participants meanwhile?
Yes,
We'll
sir.
take...
Like, sorry, sir. You have printed some metallic components in your lab, sir. Like you shown some porous structures. Sir, do you need any other support for those structures? Like there are larger pores or holes in between in those structures.
See, you, as long as far as your component or you are using the metal 3D printers or any printers, so it is necessary to start with the support structures. So that is there are some advantages and some disadvantages also, but you cannot completely eliminate the support structure. Even if it is a porous structure, you need to have support structure. See, whatever we have shown, those porous structures, it developed on the support structure only. We removed it, and what you have shown is the final one.
Yes, sir. Yes, sir. That's what I actually asked, sir. Thank you, sir.
Sir, regarding the FDM machine, I have one doubt.
Yeah, please.
Sir, whether the platform you told that is a heated bed, right?
Yes, glass plate.
And also you told that you are embedding, you're putting in over the glass platform.
Correct.
Whether that glass platform is embedded with heating wires?
Yes, that is the way it is getting heated. You can heat the glass platform with the help of that. So, hello, am I audible? Hello, Srijit?
Yes, sir, you are audible.
Yeah. Like, Saravanan, is it possible to show that?
Yes, sir. We'll take it.
If possible, you can show to him. Hello, Srijit, are you available? So can you see that it is like you can't see like explicitly, but it is like embedded inside. It is there. Heating coil is there. Okay, maybe Srijit is not available. Maybe
yes, sir. Just I went because of the net facility.
Okay, Srijit, yeah, it is there. It is embedded. Like it is not like you can see like very explicitly. Okay, that is like covered actually.
Okay, sir. Thank you.
It is, thank you. Yeah, like yes.
Sir.
Yes,
sir,
please.
Is any way to collaborate with you, sir?
Yeah, always welcome. Even Dr. Kesavan also said in his talk, like it is always not only me or Kesavan. Okay, you drop an email to IIT faculty members with whom you like to work based on your research area. People are always ready to do that. Yeah.
Actually, I'm working in the area for developing sensors using FDM, sir.
Oh, super then. Yeah, then I will also start to work with you then. Okay.
Okay.
Sure.
I'm PhD from NIT Trichy.
Oh, super. Good.
So we are having the same machine, Ultimaker Extended.
Oh, okay. Nice. Nice.
So that metal 3D printers are for that anything we need to pay or collaborate?
That is maybe Dr. Kesavan can say. If he's available.
Yeah, so Dr. Jayant.
Yes, sir.
Yes, so we have some nominal amount. So
Okay, sir.
for every hour we use the machine, that should be paid. So we have different, say for industry people to academic people to internal research scholars. So for everyone we have not that expensive. It will be nominal only.
Okay, sir.
Just to take care of the consumables.
Yes, exactly. That is the thing, because we have to maintain the machine as well as we need materials to print, right? So obviously for that we have to pay. Okay, this is as Kesavan said, even internally we are also doing that way only. Otherwise, we can't even meet our own expenses or to maintain the machine.
Sir,
Okay.
sir, is this facility like available for us? Like we, I have completed my master's recently. I'm not working with anyone, sir. Is there any like project or internship or any like I want to connect with this institute, sir?
Yes, if like you should check the advertisements. Like if any project assistant position is available, please apply for that. Obviously, there is a chance you may get it. Okay, then you can do it.
Irrespective.
Yeah, Mohammed Rafiq. Currently, what are you a student? Are you completed? You are doing any job or you're?
No, sir. Actually, I have recently completed my master's, so I just want to like, sir, get benefit of this time till I'm getting a PhD position, sir.
Would like to do PhD. Very nice.
See, there are like Dr. Subbu mentioned. There are ways to get connected. So one is through project, and other one is actually you can apply for PhD. So if you get selected, you can actually work with our group.
Yes, sir. Actually, I'm asking like irrespective of those things, like is there anything like we can directly work with?
No.